Okay, I was recently asked by a YouTube member if I could go into a little bit more detail on how my Powermatic 27 Super is set up for running cabinet door frame parts. And what I have here is both the groove or pattern cutter on the bottom and the coping or tenon cutter on top. And these are stacked in relationship so that way when I cut the tenon, the groove will line up perfectly so I don't have to do any adjustment on height. The only time if I ever want to do adjustment on height is if I were to want to change the depth of the front profile. Whenever I raise or lower this, they both move in correlation to one another and they're always a perfect fit. Here is the jig, and it's just something I made here in the shop. Basically what I do is I took two pieces of 3/4 inch plywood, glued and screwed them together to kind of give it some stability, glued a couple pieces of laminate strips on the bottom just so it kind of glides nice, and then I attached this miter gauge runner on the bottom. And the key is that you want to have this miter gauge runner perfectly parallel with your jig. Also, the other key is that your backstop that you're going to be referencing off of, which in this case is this side here, you want to make sure that this is also perfectly parallel or 90 degrees to the runner in the miter slot. So the way this works is this just sits in the miter slot like this here, and I got a couple scrap pieces here, I'll run them in a second, but basically I cut face down for this particular setup because the cutter runs this way here, so it runs counterclockwise face down. So I put my pieces in face down up against this little blowout block here, which is replaceable. I just loosen up this toggle clamp here and I can replace this. Slide it up tight against that. Use this oversized toggle clamp and I clamp it down, and I always make sure that when I set this piece in place, because there's a little bit of slop in here, so I want it to glide nice without being so stiff, I always make sure that I'm pushing against the jig with my hands, so that way the jig is against the miter slot in the shaper and this is up against the fence. And I lock down, and then when I'll push it through. When I'm done, I'll just slightly pull back a little bit and I'll pull it back through again. So that is for the coping. When I'm done coping, cutting the tenons, I'll then use the power feed in place. So basically what I'll do is I swing this into position. Roll it down. Oops, got ahead of myself here. Let me back up a step here. I have this piece of ash is what this is. And I've also mounted another long runner on this here. Now this is actually a T-track, and I could have used this just as well. My plans had changed a little bit in the development of this. With the original miter slot track that I purchased, there's some screws to adjust it so it can basically give it a snug fit. When I found out it's just too snug and it's too flimsy. So I could have used something like this here as well, using the same principle that I use right now. But basically this here will snap into the miter slot right here, and all of my style rail material will reference off of this edge or this edge depending on which width I'm using. I'm not referencing the cutting off of this fence that you traditionally would. I'm referencing off the fence on this side. So basically the beauty of this whole system is that I can have some variation of the parts going into the shaper, but when they come out on this side here, there'll be a constant, consistent width. So basically this here is set up for running my standard profile, and if I were to put it in this way here, it basically makes it 3/4 inch wider for like Lazy Susan corner doors. So if I wanted to run, after I got done running my tenons, I would snap this in place. slide the power feed in place, position it. The power feed is angled a little bit differently. Let's see if I can. As you can see here, the power feed is angling this way, not this way. Reason being is I want to be pushing against this fence, not this fence. It's important to have a little bit of an angle. If you don't have an angle, it can kind of wander either direction. And a lot of it also depends if the power feed wheels are tipped this way, or if they're not set perfectly parallel. So anyways, then basically I've got a couple of clamps, these here, which basically just slip into the end here. And I've run it without, you typically wouldn't even need that, but there's one that basically go on either end. So to get a little bit into the cutter detail, okay, so the best way to determine your height is basically you have to kind of play around depending on the thickness or the height of your cutters. This case here, I want to say my cutter is about 1.25 inches thick. What you can do is you can space this cutter out even more. The only thing is then is you basically have to build your sled up a little bit. But the thing is that you want to notice, see if I can zoom in a little bit here. If I went with one layer of plywood, the top of this cutter would be above that. So basically you got to make sure that the top of your sled is above your bottom cutter. Once you've got that figured out, that's just a matter of using the right spacers. I just have a 1/4 inch spacer here, and then I've got some precision shims. You can kind of see the spacer there, but use some precision shims, and you can find these shims. They're called shaper spindle shims. You can find them online. If you get the aluminum ones, they're great. Otherwise, you can get some plastic ones as well. You need to find the ones for the right spindle diameter. In my case, it's 1.25 inches. But from there on, then basically, once you have this approximate to where you want it to be, that's just a matter of fine shimming it. You might have to play around a little bit with this. You might have to put a piece of 1/2 inch on here, or another piece of 1/8 inch, or whichever, because the spacers, for example, I've only seen them available in I think 1/8 inch, 1/4 inch, 3/8, 1/2, 3/4, and 1 inch tall spacers. Let me grab a spacer and show you what I'm talking about. Okay, so here's a spacer. Now this one is only for a 3/4 inch spindle, but basically it's the same thing, but it's got 1.25 inch hole, and then the outside changes a little bit. So basically you would need probably at least a 1/4 inch spacer, and then you're going to need some shims. I found some here. These are some plastic shims, and basically what this will allow you to do is to fine tune the height, so that way when you cut your tenon and you go cut the groove, the amount of fuzz between the tenon and the groove is going to be very minimal. Let me grab a piece to show you what I'm talking about. Okay, when you machine this, if you have them slightly off, you might have some paper thin fuzz here, or a little bit thicker depending on how far it off is. As you can see here, it's pretty minimal. The cutter, this groove seems to be perfectly centered in the tenon, and that's the whole idea of these shims. Basically you're going to shim the cutter up to basically get it to the perfect height, so that way they line up perfectly with one another. Let me, I'll run basically a sample door here and show you basically what I'm talking about. And there you have it. Basically I made a 12 by 12 frame in just a matter of a few minutes. You know, setup time is very minimal. Once you have the cutters spaced out, you should never have to change it. So the nice thing about the tooling is, should have gone over this, but I'll quick take it apart here just to show you. This tooling is what you call insert tooling, and basically these tips are replaceable, and I can replace them with 5 different profiles this particular cutter supports. The bad news is this particular manufacturer, LRH Enterprises, went out of business a few years ago, so now there's some companies on the internet that actually have excess tips in stock. But at the same time, there's other manufacturers out there now making them as well. So, but this is the, as you can see here, I don't have any fuzz at all. I mean, this is pretty clean. So when you put it together, like that. Oops. So when you put it together, these are perfectly flush. Might have some variation here on the back a little bit, but that's the idea of running them both the same way. There's some manufacturers out there. Grizzly has them. Woodworker Supply has them, and there's some other ones out there. They make a cheap Taiwanese style rail set. It's brazed tooling. That's where the tip is actually brazed on, adhered to the body, so it cuts a single profile. And they make the one cutter, basically, I think it's the groove cutter cut face down, but they make the tenon cutter cut face up. And the problem there is if your material is not perfectly, say for example you have a lot of variation in your thickness, your groove and your tenon won't line up very well. So the only other way around that is basically you could run your tenon, your groove cutter one way, and then put your tenon cutter so it's also face down, and run it the other way. So to cut this particular one, let's just say it was face up like this here, you'd have to run the cutter this way and come in this way, and then to cut the groove you chase your spindle rotation and run it this way. So I'm not sure what the whole idea behind that is. You know, if I've found personally it's best to cut them all one way, either face up or face down. When I cut my tenons here and groove, everything is face down, and like I said, the nice thing about that is that everything will always line up. Some shops and some cutter manufacturers like to cut it face up, and that works too. I mean, you might have a slight variation in your front here, but your back will be perfectly flush. So it's best to cut them both the same way if possibly can. A lot of your router bits for your router tables, they all cut one direction, to all face up or all face down, but for whatever reason, this imported style and rail set, brazed tooling from like Grizzly and Woodworker Supply, and there's a couple other ones too, they you know, have one cut one way and one cut the other way without having to change the rotation of your spindle. So but anyways, so that'd be it. Hopefully it answers some of the questions that have been out there. Hopefully this maybe give you a little bit of an idea if you're interested in building your own as far as how you can improve it. There's a couple things I want to do to somehow make it so I can make this fence move a little bit more freely, so that way I can run different widths and stuff. But right now this is working very well for me. So anyways, I hope that answers some of the questions you've had, and questions and positive comments are welcome. Thanks for watching.